Hello everyone. Now here I am providing some beautiful observations from the concept of power relations. These observations are very important. Okay. I will promise you, if you don't listen this lecture, you will miss something from the concept of circuit analysis as well as some portion of power system. So first we have to discuss the first observation. Observation 1. Okay. From this observation 1, I am providing the difference between active reactive apparent power with respect to DC excitation as well as AC excitation. Can we have active reactive apparent power in case of DC circuits? That is what we are discussing here. That is observation 1. We all know that if we have voltage in DC circuit, that is VDC, current in DC circuits, that is IDC, power in DC circuits, that is PDC, right? Like that, in this case of AC circuits, if we have voltage, that is RMS. By default, it is RMS. We can assume that RMS quantity rise. Like that, the power is nothing but PRMS, which is nothing but P active, which is nothing but real power, right? So, by default our expectation is what? V into I is nothing but power, active power only. But here P total is equals to P apparent. That is what the difference here. Clear? So, if we have voltage and current, by default our expectation is what? Power only, V into I power. But in case of AC circuits, that power is nothing but apparent power. So, from that apparent power only we have to get active power. So, to get active power we are using power factor, which provides the some fractions of apparent power which exist in the system, that is nothing but active power. We have discussed this concept in the last lecture. Clear? So, from this P apparent is nothing but S, which is nothing but VRMS into IRMS. Clear? DC circuits, here AC circuits means what? Here the excitation is what? DC excitation, right? Here the excitation is what? AC excitation. All of you listen carefully. These are very important observations. So, this part, okay. So, first one is, for example, we consider voltage, considering V is equals to 10 volts, I is equals to 5 amps. Okay. So, in case of DC circuits, those are nothing but what? PDC is nothing but 10 volts, IDC is nothing but 5 amps, right? With respect to DC excitation, those voltage and current are nothing but DC quantities 10 and 5, like that. In case of AC, those are nothing but VRMS is nothing but 10 volts, IRMS is nothing but 5 amps. Clear? Then first we will discuss VI cos phi. What about active power in case of DC circuit? So, in case of DC circuits, we do not have the concept of phase angle. We do not have the concept of phase angle. Therefore, phi is equals to 0 degrees only. We do not have the concept of phase angle. Therefore, phi is equals to 0 degrees. Therefore, simply the active power is simply power in case of DC circuit. Therefore, the active power is simply power, that is equals to VDC into IDC, which is equals to what? 50 watts. That is it. So, we do not have the concept of phase angle in case of DC circuits, that is with respect to DC excitation we do not have any phase angle between voltage and current. That is why here there is no concept of active power, only we have simple power. The active power is simple power, which is equals to 50 watts. Clear? Coming to this case, in this case P is nothing but 10 into 5, which is equals to what? 50 cos phi, 50 cos phi, right? If we consider R load, that is phi is equals to 0 degrees, therefore, P is equals to what? 50 watts. Then only P is equals to 50 watts only. In case of DC circuits, we do not have the concept of phase angle, but in case of AC circuits, we have the concept of phase angle, but in case of R load only, the phase angle is 0. We can write here, there is a concept of phase angle. Clear? This is about active power in case of DC circuits as well as AC circuits. Clear? Next, reactive power, or you can write here the units. Units are also very important, kilowatts. Next, Q is equals to VI sin phi. The units are what? Kilovolt ampere reactive. So, in this case, see, we do not have the concept of phi, therefore, there is no concept of reactive power. Therefore, Q is equals to 0 in case of DC circuits. Therefore, Q is equals to 0, or you can write here P is equals to finite value, okay, that is 50 watts, for example 50 watts. Coming to this reactive power, Q is equals to 0, there is no concept of reactive power because it is associated with L and C. As we discussed earlier, there is no concept of phase angle. If we have L and C, obviously there is a concept of phase angle. Since Q is associated with L and C. Clear? That is why Q is equal to 0. We do not have concept of phi. Next, coming to this case, Q is equals to what? VI is nothing but what? 50 sin phi, which is equals to what? Finite value. There is a concept of phase, obviously Q is equals to finite value. There is a finite value of reactive power. There is a finite value of reactive power. Okay. Next, third, S is equals to VI. Units are what? Kilovolt ampere. That is it. So, from this, total power, right? Our expectation is what? If voltage and current is there, power is nothing but what? Voltage into current. So, in this case, VDC, IDC is there, that is 10 and 5, 50. Therefore, total power which is equals to apparent power only. So, in case of DC circuits, we can call it as total power, which is equals to what? VDC into IDC, which is equals to what? 50 watts or 50 volt ampere. Therefore, in case of S is equals to P, total power is equals to simply it is power. Since phi is equals to 0, since phi is equals to 0 in case of DC circuits, this is very important observation. Okay. So, because there is no concept of reactive power, obviously these two are interrelated, right? Simple. Assume the example of pineapple juice in the glass, that is it. We do not have any foam content in the glass, only that is why S is equals to P in case of DC circuits. Okay. In case of AC circuits only, we are having the concept of reactive power, then only the active power is always less than apparent power in case of AC circuits, because Q is what? Finite value. There is a finite value of reactive power. See, that is why S equals to P here. Here, coming to this third case, S cos phi, right, which is more than P, right. Sorry, this is the condition. S equals to P is equals to S cos phi, right. Therefore, P is what? 50 cos phi. 50 cos phi is always less than 50. 50 cos phi is always less than 50. That is, for example, cos phi is 0.8. 15 to 0.8, 40, 40 less than 50. Right? This is what? Apparent. This is what? Active. This is what? P. This is S. Always P less than S. What is the reason? Since finite value of Q. This is the reason. We have finite value of Q. This is due to what? Finite value of phase angle. So, we are having finite value of, there is a concept of phase angle, therefore, there is a concept of reactive power. So, because of this reactive power, the content of active power is always less than apparent power. But in this case of DC circuits, there is no concept of reactive power, that is why active power is equals to apparent power. This observation is very most important observation. Next, we will discuss observation 2, that is difference between complex power and apparent power. What is complex power? That is nothing but V into I conjugate, right? First we have to write complex power is the complex sum of real and reactive powers. That is, we all know that S is equals to P plus J Q, like that S is equals to P minus J Q. This is for what? Inductive load, right? This is for what? Capacitive load. That is, plus Q is for what? Is inductive reactive power, like that. Minus Q is what? Capacitive reactive power. That is, S is equals to V RMS into I RMS at an angle phi. This is about complex power, right? Okay. Then coming to apparent power is the absolute value of that is magnitude of complex power. That's it. That is apparent power. S is equals to mod S, right, which is equals to what? Vrms into Irms only. This is nothing but magnitude of complex power. That is magnitude S is equals to square root of E square plus Q square. This is the magnitude of. So from this, what is the magnitude? This is the magnitude, right? This is apparent power. Units are what? Volt amperes. Here also the units are volt amperes. Then we all know that P is equals to Vi cos phi. So from this, P is equals to, what is Vi into Z I, what is cos phi? R by Z. Since cos phi is equals to R by, we all know that from impedance triangle, right? From impedance triangle. Like that, what is cos phi? Sin phi? X by Z, right? Therefore, P is equals to what? I square into R watts. This is real power. So, P, I square R is nothing but real power, where P is not equals to P square by R. This is very important observation here. Active power is nothing but I square R only. It is not P not is equals to V square by R. See, in place of V as it is I V by Z. So cos phi R by Z, we don't get V square by R. So we are dealing with respect to complex power. That's why P is equals to I square R only. It is not is equals to V square by R. Kindly make a note, right? It's very important. P is not equals to V square by R in this case. Like that, second one, we all know that Q is equals to Vi sin phi. Therefore, Q is equals to I into Z into I. Sin phi is what? X by Z. Therefore, Q is equals to what? I square into X, right? I square into X, where QL is nothing but J I square XL, QC is nothing but minus J I square XC. QL is nothing but what? Inductive reactive power. QL, capacitive reactive power, that is QC. QL equals to J I square XL, QC minus J I square XC, right? That's it. V square by R, I square X. It is not only it is I square R, it is only I square X. That's it.